Welcome to today's lesson on electrolysis. In this session, we will explore how electrolysis works for different compounds, identify products formed at electrodes. Electrolysis is the process of breaking down a compound using electricity. It requires three key things: an electrolyte, which is the ionic substance; electrodes, usually made of graphite or other materials; and a power supply to drive the reaction. You can click the link on the top right corner to watch the full video on electrolysis for deeper understanding. In electrolysis, the anode is the positive electrode, where oxidation occurs. The cathode is the negative electrode, where reduction occurs. Cations, which are positive ions, move towards the cathode. Anions, which are negative ions, move towards the anode. A quick way to remember is anox, meaning oxidation at the anode, and red cat, meaning reduction at the cathode. When more than one type of ion is present in an electrolyte, not all of them are discharged at the electrodes. Instead, some ions are released preferentially depending on three key factors. These are the reactivity of the cations, the concentration of ions, and the nature of the electrodes. Note: if a question asks why a certain product is formed, always refer to one of these factors. Let us look at the discharge rules. At the cathode, hydrogen is discharged instead of reactive metals such as sodium, potassium, calcium, or magnesium. This is because hydrogen is lower in the electrochemical series. But less reactive metals like copper or silver are discharged instead of hydrogen. At the anode, halide ions like chloride, bromide, and iodide are discharged before hydroxide. If no halide is present, hydroxide ions are discharged, producing oxygen gas. Remember, cathode loves the less reactive cation, anode loves halides first. Let us apply the rules. In concentrated sodium chloride solution, hydrogen is released at the cathode, and chlorine is released at the anode. In dilute sodium chloride solution, hydrogen is still released at the cathode, but oxygen is released at the anode. In copper sulfate solution with inert electrodes, copper is discharged at the cathode, while oxygen forms at the anode. Next, we will look at electrolysis of some compound individually. Learn how to identify the products formed at the electrodes. Predict the products at each electrode. And write ionic half equations. Let us start with molten lead bromide. The ions present are lead ions with a charge of 2+, and bromide ions with a charge of -1. At the cathode, the lead ions gain electrons to form lead metal. At the anode, the bromide ions lose electrons to form bromine gas. Observation: a grey metal deposit forms at the cathode, and a reddish-brown gas is given off at the anode. The half equation at the cathode is lead 2 ++ 2 electrons gives lead. At the anode, 2 bromide ions form bromine gas plus 2 electrons. Now let's consider concentrated aqueous sodium chloride. The ions present are sodium ions, chloride ions, hydrogen ions, and hydroxide ions. At the cathode, hydrogen is discharged instead of sodium because hydrogen is lower than sodium in the electrochemical series. At the anode, chloride is discharged instead of hydroxide because of its higher concentration. Observation: bubbles of hydrogen gas at the cathode and greenish-yellow chlorine gas at the anode. At the cathode, 2 hydrogen ions plus 2 electrons give hydrogen gas. At the anode, 2 chloride ions form chlorine gas plus 2 electrons. With dilute sulfuric acid, the ions present are hydrogen ions, sulfate ions, and hydroxide ions. At the cathode, hydrogen ions are reduced to form hydrogen gas. At the anode, hydroxide ions are discharged to form oxygen gas. Observation: bubbles of hydrogen at the cathode and oxygen at the anode. At the cathode, 2 hydrogen ions plus 2 electrons give hydrogen gas. At the anode, 4 hydroxide ions form oxygen gas, water, and 4 electrons. In aqueous copper sulfate with inert electrodes, the ions present are copper 2+, sulfate 2-, hydrogen, and hydroxide. At the cathode, copper ions are reduced to copper metal. At the anode, hydroxide ions are discharged to form oxygen gas. Observation: a reddish-brown layer of copper forms at the cathode and bubbles of oxygen at the anode. At the cathode, copper 2++ 2 electrons gives copper metal. At the anode, 4 hydroxide ions give oxygen gas, water, and 4 electrons. When copper electrodes are used instead of inert electrodes, the reactions change. At the anode, copper metal dissolves. Each copper atom loses 2 electrons to form copper 2+ ions. These ions enter the solution. Note: the mass of the anode decreases during this process because copper atoms are leaving the anode. At the cathode, the copper 2+ ions from the solution gain 2 electrons. This forms copper metal, which is deposited on the cathode surface. Overall, copper dissolves from the anode and is deposited at the cathode. This means the mass of the cathode increases as copper is deposited, while the mass of the anode decreases. Let us answer an exam past paper on electrolysis. Figure 4.2 shows the apparatus used for the electrolysis of dilute sulfuric acid using graphite electrodes. You are asked to label figure 4.2 to show the cathode and the electrolyte. Name the products and state the observations at the positive and negative electrodes. You can pause the video to give it a try. Here are the answers to the questions. Let's take a moment to test your understanding of what we've covered so far. Study and write the correct answers to the following questions. You can pause the video if you need more time and also re-watch to answer the questions. Thank you for learning with AceStudents. If you found this lesson helpful, be sure to check out our playlist for more videos. Every video includes evaluation questions to help you test your understanding. Our content is perfect for homeschooling, Google Classrooms, or private tutoring. Don't forget to subscribe and click the notification bell so you never miss a new science lesson.